Hello everyone, and welcome to this video titled Graphs of Functions Based on Rules. In this video, I'm going to be going through several examples taken from the adaptive practice at a website called ck12.org, and I'm in their Algebra 1 text. All right, so here we are at ck12.org and their adaptive practice called Graphs of Functions Based on Rules. I'm going to be working through the first 5 of the 10 in the adaptive practice. And of course, you can go into this text yourself, finish up the 10, and keep practicing further after that if you wish. I would highly recommend that as I work through, try, every time a new example comes up, pause the video and try to work it out yourself before you see me doing it. All right, so in this first example, we're asked, is the graph below increasing, decreasing, or neither? Right, so when you're given the graph of a function like we have here, right, and we can tell it's the graph of a function, right, this red graph, because every single value on the horizontal axis corresponds to a point, exactly one point, right, exactly one value on the vertical axis, right? Every input corresponds to exactly one output in this red graph. Right, so we do have a function here. Now, they would say that a function is increasing if, as x increases, the y values are increasing as well, right? So when we are asked about a function being increasing or decreasing, we're going to look at the graph of the function from left to right. Left to right. As x increases, what happens to the y? So here in this red graph, as x increases, we can very clearly see the y coordinates of the points on this graph are increasing as well, right? 1 here, 2 here, 3 here, 4 here, 5 here, 6 here, and so on. So this particular function would be considered increasing. Of course, if it was decreasing, then the red graph would be going down as I went from left to right. And if it was neither, it would be going down in some places and then up in other places, right? Down then up or up then down. Not up the whole time or down the whole time, but here it's going up the entire time I'm looking at this. So this would be considered an increasing function. That's choice A. And I'll check it out. Great. Right. And that's it for this first one, right? Pretty simple one, just looking at a graph and, understanding the definition of, whether a function is increasing or decreasing. What does that mean? All right. Next example, another graph. And using this, these same terms, right, is the graph of this red function, increasing, decreasing, or neither. Once again, when we're asked that question, look at it from left to right on the xy plane. As the x coordinates increase, as I go from left to right, what's happening to the y coordinates, right, the values of the function? Well, for this particular graph, as we move from left to right, we can see the values of y, the values of the function are decreasing. All right, 5 here, then 4, then 3, then 2, then 1, then maybe about a half, quarter, an eighth, or something like that, right? But we can very clearly see that as you move from left to right, as the x values increase, the y values are decreasing the entire time. So this function is decreasing, which is choice B. I'll check it out. Wonderful. So now we're asked to actually, do what the title of the adaptive practice says, right? Graph a function based on a rule. And here is a rule. F of x, right? This is called function notation. We have a function called f. And then in the parentheses after the name of the function is the variable representing the inputs. So I have f of x equals, and then over on the other side, an expression depending on that variable x that tells us how to calculate outputs. We take the input x, divide it by 6, and then add 4, and that'll give me the output. And we're asked to graph this particular function, and they give us some choices here. What I'm going to do is I'm going to go to the Scratchpad. I'm going to write this function out and show you what we're going to be doing. And it's just like a previous video where you have an input variable and an output variable. You have inputs and outputs, and each pair of inputs and outputs will represent a point on the XY plane. You start plotting these points for different inputs and outputs until you see a pattern forming. Right, so the particular function, for this problem was this, f of x. So again, you see this here. This is f of x, all right, not f times x. This is called function notation. So we have f of x equals, and then over on the other side of the equal sign is how do I take this input called x and calculate an output? And the output is x divided by 6 plus 4. So, as I mentioned, in function notation, write some more about function notation here. The letter or symbol to the left of the parentheses is, the name of the function. So this would be called function f. And then the variable inside the parentheses after the name of the function is what's called, the input or the argument. I've also heard it called the argument before. And then f of x, right? The entire thing represents the output, right? How and then over, and it's equal to this rule over here. All right, this entire rule on the right side is how you calculate the output. All right. So I'm going to make a little chart. We'll have inputs x and then outputs called f of x, right? What is f of x equal to? Now, if I were to start with, say, 0, here's how we're going to write this out. I replace x with 0 throughout this. So f of, 0, this tells me the input is 0. And then over on the other side, we do a calculation, right? 0 divided by 6 plus 4. And after simplifying, we get f of 0 equals, 0 divided by 6 is 0, plus 4 is 4. And then the output is 4. So input 0, output 4, right? And we would say that f of 0 is 4, meaning that when the input is 0 for this function f, the output is 4. So then on my xy plane, if I were to I'll make a small drawing here. There's the y-axis, there's the x-axis. I'll plot the point 0, 4. I'll do it in blue. Right? So 0 and then 0 on the x, 4 on the y. There we go, right? 0, 4. Plot that point. Then some other points we could plot. If x were, now I'm going to plug in 6 for x because you see how it's being divided by 6, right? We have x divided by 6. So if I plug in multiples of 6 for x, that'll give me a nice integer output. If I plug in a number that's not a multiple of 6, then the output will be something that's not an integer. Okay, so come down here. Well, let me erase this f of 0 stuff. And we'll plug in 6 for x now. All right, so f of 6 is, and then over on the right side again, how you calculate the output. Replace x with 6, right? So we have 6 divided by 6, and then plus 4. This would be 1 plus 4 or 5. So the value of f at x equals 6 is 5, right? So we have 6 on the x, so there's 6 on the x-axis, and then 5 on the y, and there's another point. Now I'm hoping you can tell, and I'll plot this point. There's the ordered pair, 6, 5 right here. Now I'm hoping you can see that if I plugged in 12, we'd get 2, right? So it's 12, 2. If I plugged in -6, right? In fact, let me do that. Let me plug in -6 right now. Let's do one more point here. So I'm going to plug in -6 for x. And then f of, -6 would be -6 divided by 6 plus 4, which would be 3, right? -1 plus 4 is 3. Right? So we'd have, on the x-axis, I put in, go to -6 on the x, 3 on the y, and that would be, this point here on the coordinate plane. There it is, -6, 3. Right? And I could do this all day long, plug in all sorts of x values, get all sorts of y values, all sorts of inputs and output pairs, and plot them. And I'm hoping you're seeing a pattern here, right? Look at these 3 points. They're all falling on the same straight line, right? So the graph of this looks to be a straight line graph going that way forever and that way forever. And based on our first examples, the first 2 problems in this video, this particular function would be called an increasing function. So in fact, I'll write that under here. I'll say f, right? The name of the function is f. We can say that f is increasing, right? As I go from left to right, as x increases, the y coordinates are going up all the time, right? But anyway, that's not, we're only asked to look at the graph, and that looks like choice D here, right? This is a parabola. This is looks like we'll talk about exponential functions in later videos, I'm sure. Here's another parabola. Now this graph F is the graph of a line, choice D. Wonderful. All right, so moving on. But again, I hope you see what's going on here. Right. Just like any other XY equation, right? If this was like an equation with x's and y's in it, we're plugging in values for x, getting values of f, which could also be called y, inputs and outputs, plotting points, pairs of inputs and outputs, and then after enough of them, hopefully you see a pattern forming. All right, now this one's a little different. We have f of x equals, and then, so the input is x again, the function is called f again, and then the output is calculated this way. You're taking the square root of 2 times the input, right? The square root of 2x. Right, so I'll tell you right now, this will not be a straight line. In fact, we can't plug in whatever we want for x. You can't take, square roots of negative numbers. And, if you want a real number output, right, square roots of negatives are what are called imaginary numbers, which I'm sure will be talked about in a future video. So really all I'm seeing here is the square root of something, square root of 2x, and this needs to be positive, right, or non-negative. Right, so I can plug in 0, I can plug in positive numbers, and that should be fine. So once again, let me go to my scratch pad here, and we'll make a chart, make a table of pairs. So here is the rule, right? The function's called f again. The input is called x. And then on the other side is how we calculate the output, the square root of 2 times x. All right, so once again, I'm going to make a little chart here, x, right, input x, and then output f of x, right? And again, f of x can be called y if you want. You can replace the f of x with y, and this would be exactly the same equation, right? Y equals the square root of 2x. All right, so if I were to plug in 0, right, the square root of 0, right, 2 times 0 is 0. Square root of 0 is 0. Now, if I were to plug in 1, right, this wouldn't be a very nice number, but if I plug in 1 for x, we'd get the square root of 2 times 1, right, the square root of 2. So input 1, and then the output would be the square root of 2, which, is about 1.414. Obviously, that's about 1.4. So when I start plotting this, horizontal x, vertical y, or f, uh, when I start plotting this, we have 0, 0. Right, you got the origin on there, right? Input 0, output 0. And then input 1, and then the output would be, the square root of 2, which is somewhere between 1 and 2. It's about 1.4, so like there. Something between 1 and 2, but closer to 1. Right, then I'll plug in 2. That'll give me the square root of 4, which is 2. Right, so you have 1 square root of 2, 2, 2. And just from these 3 points alone, it looks like, the graph is not a straight line. Right, so I'll plot some more points. Now, if I were to plug in 3, right, 2 times 3 is 6, you get the square root of 6, which is something between 2 and 3. What I'm going to do now is I'm just going to plug in numbers that'll give me some nice square roots, right? Numbers that'll give me square roots of perfect squares. So 2 is fine. 8 would be good, right? If I plugged in 8, you'd have the square root of 2 times 8, the square root of 16, which is 4. So 3, 4, 5, 6, 7, 8. If I plugged in 8, I get an output of 4. So here's 8, 4. And again, I'm not. Now, if I were to plug in 9 halves, you'd get 3. Right? If I were to plug in 4.5, here's 4, here's 5. If I were to plug in 4.5 or 9 halves, you'd get 3 for the output square root of 9. And at that point there, but hopefully you can see that this is going to be like a half a parabola. The shape is looking like this as I keep going further to the right. And it's still increasing, based on our definition from earlier. F is an increasing function. As the x coordinates increase, the y coordinates are increasing as well all the time, right? As I look at it from left to right, the graph is going up. So based on the rule and my plots of ordered pairs, plots of points here, looks like this is the shape of this graph, which is once again choice D among all these other choices here. And wonderful. All right. This is it. When you're asked to graph a rule, right? Graph a function based on a rule. You're plugging in inputs, getting outputs, and every input-output pair represents 1 point on the coordinate plane. And you just keep plotting points on the coordinate plane until hopefully you see a pattern. And after enough time and practice, you'll have seen enough of these, to know when a rule looks like this. You have the square root of something with x, or the previous example where it was x divided by 6 plus 4, you'll be able to hopefully look at a certain rule and have a rough idea, based on prior knowledge and prior experience as to what the graph is going to be shaped like. All right, so I'm going to do one more of these. And we're given another rule. Function f of x equals, and then here it's x divided by 3 plus, and then x squared divided by 9, right? So once again, this doesn't always happen, but the function's called f, the input's called x, right? Again, it's not always like this, but for this first video it is. And then over on the right side is how the outputs are calculated. Right? Now, like I said earlier, you should, with practice and experience, enough of these, you'll see this rule here and say, oh, there's an x squared, as the highest power of x. There's no special symbols, no square roots, no absolute values, no nothing. And based on that, I've got an x squared with a positive coefficient as the highest powered term, positive 1 over 9, 1/9 here. I know from experience that this will be a parabola, one of those U-shaped graphs that's opening up. So not A. So maybe B, maybe C. All right, so it might be B, it might be C. All right. Now I'm thinking it's going to be C because if x were 0, right, if you plugged in 0 for x, the output would also be 0. So not only is it going to be one of those parabolas opening up, but it's got to have the origin on it. It's got to have the point 0, 0 on it. All right, so it must be C. Now I'll plot some points. All right, I'll do the scratch pad here. Show you some ordered pairs. Right. So we had f of x again, right? The function called f, the input called x, and then how the output is calculated is x divided by 3 plus, and then x squared divided by 9. And once again, I'll make a little chart, little table with inputs and outputs, right? X and f. And as I said earlier, right, input 0, output 0, right? 0 plus 0 divided by 3 plus 0 squared divided by 9 is 0. If I were to plug in, now the reason I'm going to plug in 3, right, is because we're dividing by 3 and 9 and things are being squared. 3 divided by 3 is 1, 3 squared is 9, divided by 9 is 1, 1 plus 1 is 2, right? So input 3, output 2. And I'll start plotting some of these, right? So x-axis, y-axis. Right? As I said, you got, the origin is on it. Input 3, output 2, right? So there's another point. If the input were -3, right, then you'd have -3 divided by 3 is -1, plus, and then -3 to the second power would be +9, right? -3 times -3. So 9 over 9 is +1. -1 plus +1, that's 0. So you'd have input -3, output 0. So there's this point here. And I could plot more points, but what you're going to notice is that the graph will do something like this. It will be a parabola like this, a U-shaped graph opening up, going through these 3 points that I plotted here, -3, 0, 0, 0, and 3, 2. And I leave it to you if you want, plug in other values of x. Maybe using graph paper would be nicer as well, instead of doing little hand drawings, because this isn't a great looking drawing. But if you have some graph paper on hand, that might make things a little nicer. But yeah, so plot more points, see a pattern, fill in the rest of the pattern, and you'll be seeing this parabola shape opening up, going through the origin, going through the point -3, 0. Right? And those would be considered, right, the x-intercepts, right? Remember the intercept are points on the axes. X-intercepts are -3, 0, 0, 0. The y-intercept is 0, 0, right? So the only graph that's doing that is graph C here. I know you can barely see the intercepts, but they're there. Graph B is also a parabola opening up, but the intercepts aren't the same. You get 1, 0 and -4, 0, and the y-intercept is 0, -4. That's not the correct graph. Let's check it out. Wonderful. And that'll do it for me for this video. Like I said, I'm going to just go through 5 of these. Leave the rest for you to do if you wish. And you got a couple definitions out of here, right? What does it mean for a function to be considered an increasing function or a decreasing function? And also, you got your function notation introduced to you here, the name of a function followed by the input, the name of the input variable. And then on the other side should be how to calculate the output. And then just like any other graph you're making on the XY coordinate plane, you plug in inputs get outputs corresponding to them, plot those pairs, and plot enough pairs to hopefully where you're seeing a pattern, and then you fill in the rest of that pattern. Um, yeah. And so I'm hoping hoping this video, these 5 examples here help you out when you're doing this stuff on your own. And thank you very much for watching.